Hello, everyone. Welcome to another episode of React Wednesdays. Today, I'm joined by my fantastic guest, Josh. Thank you so much for coming on.
Thanks for having me. It's a good time. How are you doing?
Doing all right. You want to go ahead and give us a little bit of introduction? Tell our viewers who you are and what you do.
Absolutely. Hey everyone, I'm Josh Goldberg. I'm a full-time open source maintainer in the TypeScript ecosystem, which means rather than having a job at a reputable organization or company, I independently work on open source projects that I find to be interesting and can get me exposure in the world. The most notable of those is TypeScript ESLint, which is the tooling that lets you run ESLint and Prettier and other common JS tools on TypeScript code. Fun fact, it is neither TypeScript nor ESLint. It's the thing that bridges those together. I'm also the author of O'Reilly's Learning TypeScript book. Buy it now. Very excited about that. And a Microsoft MVP for dev technologies. So I do a lot of work around yelling about TypeScript at people who may or may not want to hear it.
The good news is we want to hear it. And that's why we brought you on, in fact, to give us the TypeScript introduction, right? Because I think I am one of those people who embarrassingly has barely touched TypeScript. I worked for a little bit at a company that wrote Angular for their application, and that ecosystem seems much more tightly bound, right? The Angular TypeScript situation is just very different from the React TypeScript situation.
Yeah.
So I did it for just a little while, just enough to get not very good at it, and then I switched back to React and immediately forgot everything that I learned. But it seems more and more like things are swinging that direction, that regardless of what framework you're writing with, TypeScript is kind of becoming the new standard. Is that correct? Or maybe just the people that I hang out with are very excited about it?
Yeah, I don't know. It's hard to tell because we're in a little bit of a bubble in that we're surrounded by all these influencers and notable
Yes.
companies that use TypeScript. But I think the way I would describe it is it's one of the best things you can choose to do in your code base. You don't have to use TypeScript. It's fine to just write normal JavaScript on your own. But as soon as you start working with other people or maybe have a project you want to live for a long time, it's a weird choice not to use TypeScript. I think that's the state the industry is in my opinion.
Interesting. So
Visual Studio's rating. That's cool.
So if you're writing totally by yourself, side project kind of thing, no real need. What's the big benefit then that TypeScript offers in that collaboration facet?
Yeah, there's no need. You don't need to do, but there are a lot of benefits to TypeScript. The way I describe it is so there's when to use it and then why to use it. When to use it, I personally go with a rule of three. If there are at least 3 files or at least 3 people working on something, then I'll probably just use TypeScript because it's really useful in letting you know when you update something in one place and then another place needs to be changed as a result.
Okay.
But TypeScript really has, again, the number 3, I think 3 big benefits. It will catch bugs for you. I've never seen a large project converted to TypeScript without finding shocking bugs in production, which is great. Love to see it. It is a really good documentation format. It's a standard way to describe the intent behind your values, whether something is, say, nullable or only a string or some weird complex object. And it makes your dev tooling better. It allows a lot of really nice things like go-to definition, find all references, rename in editors like Visual Studio and Visual Studio Code. And it makes tooling like ESLint, thanks to TypeScript ESLint, a lot better. So they can find better bugs and do more standardization efforts across your code bases. Ta-da!
Nice.
That's TypeScript.
That's good. That's a very solid elevator pitch. Because I am interested.
Yeah.
So one of the things that I was interested that I heard you say was talking about applications or companies that will move to TypeScript or migrate a project to TypeScript. How challenging is that? That sounds like it would be challenging and quite a bit of work.
It is challenging and quite a bit of work if your team does not already know TypeScript. I mean, any technological shift, whether it's a language or a framework or a style of doing things, is going to take work. And that actually brings up one of the downsides of TypeScript. I think it would be foolish to discuss TypeScript and not consider the fact that there are always downsides to any shift. And for TypeScript, it's complexity and the fact that you need to learn things. TypeScript exposes the complexity in your logic. It forces you, or you can configure it to force you to explicitly describe the weird and wacky, renames or logic shenanigans that you do in your code. And if you're not super familiar with TypeScript and you are in a code base that has opted to describe those things, it can be confusing. Plus, with any new language, there's just the time it takes to learn it. No one just plops out of the heavens into the world with TypeScript knowledge. You got to read a book or try it out.
Right. I mean, that's true of any new technology, though. And that's something that, I think all of us are probably, if not in the job because we specifically enjoy learning, we have at this point at least resigned ourselves to the fact that that's a requirement for being a developer or software engineer. So that part doesn't sound too intimidating to me. But some of the complexity I could see being a little bit challenging. Are there things that we can do to kind of mitigate that, or like patterns we can follow, or
I'd say
sorry, I'm probably like jumping way ahead because I was like, we're gonna talk about TypeScript for beginners, and then I'm like, tell me about patterns.
Oh my god. No. This don't worry, this is still within that context.
Okay, good.
It's good for beginners to know that TypeScript is very configurable. A lot of like big fancy schmancy code bases that were written from the start in TypeScript opt to use the strictest forms of TypeScript, but you don't have to, especially if you're new to TypeScript or you're onboarding onto a new code base. You can tell TypeScript to be very forgiving, and to the point of it's not giving you nearly as much value, but not requiring you to learn as much. There's the any type, ANY, referring to this value could be anything. Don't yell at me if I use it wrong. Shut up about it. It's fine. AKA the YOLO type. And in general, any's are bad. You don't want them because they tell TypeScript to shut up. Like they remove some of the use. But if you're just getting started with TypeScript, if you're migrating a large existing code base, you don't have time to exhaustively figure out every type, it's fine to sprinkle a bunch of any's in there and get to it later.
So it's a little bit, it sounds to me like defining prop types in React, right? In the same way that you can kind of say like, expect this to be this and throw a flag if it's not. Is that mostly accurate? Or
Yeah. I think prop types in React are a good way to think about TypeScript, some of the benefits and like the way that TypeScript works. Prop types in React are really interesting because they are a runtime validation, whereas TypeScript generally exists only at development time. There are like weird and wacky ways to like take your TypeScript code and turn it into runtime things, but we don't like that. It's one of the big benefits of TypeScript is that it is just a development time utility, that any TS or TSX file, the TypeScript extension, becomes a JavaScript file with, roughly speaking, just the new TypeScript stuff removed, which makes it a lot easier to understand TypeScript if you think of it just as a bunch of things added only at dev time to JavaScript.
Gotcha. So in that way, kind of like a preprocessor for CSS, right? And if you're writing like a Sass file, by the time it hits the browser, it's just a good old fashioned CSS file, right?
Boom. I actually really like that analogy. Yeah. It's like Sass. Yeah.
Cool. All right. So does it actually, in that vein, does it extend actually what JavaScript is capable of in the same way that Sass kind of extends what CSS is capable of? Or is it more about kind of fitting what already exists into a more structured
It's about
existence?
Good question. Thinking how to phrase this. It's about describing the intent of your code. There are, with the exception of a couple of very old features that are somewhat controversial, people generally don't like to use them. TypeScript does not add new runtime stuff to JavaScript. It's not like you declare a function in TypeScript and it's some new and wacky different way of doing things from JavaScript. It's that TypeScript lets you write the same style of JavaScript code as before, but with better described intent and with tooling to let you know if you screw it up. So technically speaking, TypeScript is an approximate superset of JavaScript, meaning the language TypeScript, it contains the language JavaScript. It's all the same JavaScript syntax. Plus, in addition to that, there are some new syntaxes, which you basically can consider to be fancy comments. And these fancy comments are a way of describing your code. And fun fact, there's actually a proposal to add some of those comments to JavaScript, the language, as comments.
I have heard about that like
Yes.
more and more stuff from TypeScript is kind of making its way over into vanilla JavaScript. So I want to come back to that later because I do have some questions about that, but I don't want to. I think we're on a good track right now, and I want to highlight some of the comments we've been getting.
Sure.
So
love this.
Good old Hell Reaper here says, I've been learning TypeScript recently in my spare time, and I'm never going back to JavaScript, which seems to be a very common sentiment. I would be interested if you wanted to tell us a little bit more commentary about what you love so much about TypeScript that really sold you.
Yeah,
I too haven't yet.
Yeah, I sometimes go back to writing JavaScript, and unless it's like a real quick script, like one file, I have a hard time without TypeScript up there. TypeScript it's just so much better of a development experience writing TypeScript for me and for many, because you get so many better dev time utilities. Like you get suggested imports if you start writing function calls from that would need to import something from a module. If you start typing out, like if I have a variable, let hello equals some object, and you start doing hello dot, like you'll get auto completions that are intelligent. And if you need to describe what a function takes in, you can say what the types of the parameters are, so that later on, if you call the function and you type in the left parentheses, then it'll start telling you what all. It's just all these little things that make it so much nicer to develop. Like the difference between writing in a plain text, like text editor, Notepad++,
yes,
versus an editor. It's that same jump in quality.
So you're looking at those of us that are still writing JavaScript the way we look at people who like open a Microsoft Word file and are like, going to write some code. You're like, why would you do that?
Yes. I have never actually seen someone specifically use Microsoft Word to write code, but I have seen Word.
No, I picked something egregious.
Yeah. Yes. Yeah, basically. I mean, it's a valid way of doing things. And I learned to code in college, I learned like on Ubuntu with like the default text editor in Ubuntu, no IDE, and that was totally fine. But then when I started using whatever VS Code, Sublime, and so on, it was just so much better.
You can never go back, right?
I can't go back. Yeah.
We did get some good comments about benefits of TypeScript, which I want to bring up mostly as a way to let you talk about those.
Sure.
So, error 404. I don't know if this is real or sarcastic. This feels sarcastic.
I think they're trying to use AI to write a Twitch comment. I'm not sure.
Impressive.
Trying and not succeeding.
Yeah. This one, however, feels incredibly genuine. Talking about type safety, especially for folks that came from a typed language background. So can you tell us a little bit about, I mean, typing rate is just that definition of saying what to expect, right? Mm-hmm. Or is there more to it than that?
There can be more to it than that. I mentioned that TypeScript is a dev time thing, that its types generally aren't available at runtime. You can't ask at runtime, does this variable satisfy some interface? There are libraries that approximate that behavior, but TypeScript itself, no. Other frameworks or paradigms like C# do have types available at runtime. They work in an environment like, say, .NET, where you have compiled code that is available. So it is a little different from something like Java or C#. But that being said, a lot of the benefits are shared. Like types allow you to describe how code is meant to be done. Interfaces in TypeScript are really nifty. You can say that, let's say a function takes in an object, like a settings or options object, and the object must have these 3 properties, and it may optionally have these 5 properties. And each of these properties has a type, which might be like a string, or like specifically these literal numbers, 1 or 2 or 3, or it might be another object, and so on and so forth. And if you've ever had to call a complex function like that in your code and had to memorize, like, what are the 15 different objects or sub-nested objects that I have to know to call it, it's a whole pain in the butt. So TypeScript and other type languages make it a lot easier to call that stuff. And then also to describe, if you're the one creating that complex function, how are you supposed to call me with what? Gotcha.
I'm enjoying, this is not a metaphor that made this any more helpful to me, but I like it, and I bet there are people for whom this is helpful. Also, hey Fuel, welcome back. We're glad to see you again. I evidently need to pick up electrical work, or maybe you do, since you're already halfway there. If you understand TypeScript and how TypeScript works. But
I'm on the Wikipedia for this now, and it's not helping me. So file on
Yeah.
that for after the stream.
I've never been like a hardware person. I know there are lots of developers that kind of edge over into that side of things, but honestly, I kind of just, it seems silly to say I just want it to work when I am then immediately going to sit down and write something on it that does not work. But I want the hardware to work.
Fair.
So the
Yep.
only thing that I have to fix is the stuff that I've done myself.
Agreed.
Good. Okay, so for folks that are totally just getting started, what do you think is like basics need to know? What's the kind of entry point if you were to like walk us through?
Sure. So I'd say you can learn TypeScript without previously knowing a lot of JavaScript. A lot of people do that if they need to switch over because they like switched a role or their company is using it now or something. But my recommendation, if you have the time, is to first learn JavaScript. Not expert level. You don't have to know everything about like symbols and resolvers and whatever, but like know functions, first class, like array methods, objects, and then learn TypeScript. That's my general recommendation, and that's what I say in Learning TypeScript, the book, that like TypeScript does not add runtime things with very few old exceptions. So TypeScript just models how JavaScript works. So if you have a solid understanding of JavaScript, then you should be fine. But as to how you actually get started, I recommend, honestly, try out TypeScriptLang.org. It's the TypeScript website. It's got a pretty darn good set of documentation and a really nice interactive playground.
What was that website? I want to go ahead and share it in the comments. It was TypeScript.what.org.
Too slow. I already shared it in the comments.
You're so good. You're doing my job for me.
Try to be a good guest.
Cool. So TypeScriptLang.org, and obviously your book as well, I would say, right? So
yes.
Even if you won't promo that, I'll give you a little promo on that for those of you that might have joined a little bit late. Josh here is also the author of Learning TypeScript, which is an O'Reilly published book. So you can check that out. I'll go ahead and add. I don't think we were sharing your screen, but now we are.
Oh, we weren't. I forgot that I had this share up. Oh, wow. That got off lucky there. Yes. So yeah, this is my book. Thank you for letting me promote this. I think it's pretty darn good, if you don't mind me saying so. But before you purchase a book or do an O'Reilly free trial or whatnot, for any document or for any programming language, I always recommend folks just go to the website. TypeScriptLang.org is the website for TypeScript. It's pretty great. It has a lot of good explainers, a lot of the stuff that we said, and a nice little handbook that goes through kind of like how TypeScript got started, how this handbook got started, and then like the foundations of TypeScript.
Nice.
So, yeah. One of my favorite things also is on this website, the TypeScript Playground, TypeScriptLang.org/play. It's on the header there. On the left, you can type your TypeScript, and on the right, you get the equivalent output. So, for example, if we say console log hello world in TypeScript, I mentioned TypeScript is a superset of JavaScript. It's JavaScript plus new stuff. There's no new stuff here, so the output is just the same, console log hello world. By the way, Kathryn, I warned you ahead of time. I would ask you this. What's your favorite emoji?
Ooh, favorite emoji. You did warn me, and then I didn't tell you. I think in the standard emoji set, I end up using, I think she's technically like the information girl, but she's the one that goes like this. She's got her hand up. She's like, it's very sassy. Okay. I will find it and tell you.
Hand up. This person?
Yeah.
Oh, wait, you're not seeing my Mac.
I didn't see it. Oh, no, not the raised hand girl. Hold on. Oh.
Okay. I'll answer. Someone asked in the chat, what is use strict? Yeah, use strict is a very old thing in JavaScript. You don't have to worry about it anymore. JavaScript, the language, has a few quirks. And if you put this string, as it's called a directive, a comment directive. A prologue directive? Shoot, now I forget. Anyway, it tells JavaScript to be a little more strict and don't allow some wild and wacky stuff. This is not a TypeScript thing. This is an old JavaScript thing. Don't worry about it. It doesn't come up in modern JavaScript, in my experience.
Okay. I'm going to distract us for 2 seconds by sharing my screen so that you can see the emoji that I'm talking about. And then I promise we can get back to TypeScript. It's this girl. I can't believe that this wasn't like a striking representation of that. So this is,
okay.
This is my girly. You don't have to use her though. It's okay.
No,
Okay.
it's too late. I've already decided to use your
She feels
suggestion.
very
There you go.
saucy. And so sometimes people are like, are you sure that's what you want? It's like,
Like,
mhm.
yes, it is. Great.
Yes.
Anyway, the whole point of
But
this was to show that it's a real-time editor that, like, as you type in on
yes.
the left, in real time, things appear on the right, such as emojis. So great.
There was another comment that I did want to bring up because I thought it was a good question, or I guess just note. Where Phil says that there are some folks, smart folks even, that he knows, who would say that types get in the way of productivity. And I can kind of see where the argument for that would come from, right? Because it, as described, it's more work, right? It kind of slows down the development process a little bit. And I would assume the response to that would be you get that time back in the bugs that you catch and don't have to solve later. But I mean, is that true? And I mean, if we're being honest, how much do you think it slows down the development experience as compared to vanilla JS?
I'm resisting the urge to just outright say, how smart are they if they have this opinion? Because it's a valid opinion. And I really hate this tech drama culture we live in. It's a valid opinion. And you bring up a good point. The downside is always going to be there. As you get more and more experienced with TypeScript, it'll be less of a downside. But I think once you're familiar with the language, once one is familiar with the language, I don't see it as being a net negative. I have seen so many benefits in myself and in the teams I've worked with or helped with TypeScript that they just work so much more quickly with types, that they have fewer bugs, that they're able to code faster, similar to how Copilot like gives you IntelliSense and hints. TypeScript has been doing that for years. It's like wearing, it's like wearing fancy hiking boots instead of going in your like nice walking shoes. Like, yeah, if you're going on a quick little walk around the hill, then maybe your fancy schmancy hiking boots aren't relevant or useful. But like, we're all hiking big mountains repeatedly as developers, so it's worth it. I will say though that
comparison. That's good.
Thanks. I will say though that again, I want to be clear that everyone is different. There are always pros and cons, and there's no one correct thing here. It's not TypeScript good or TypeScript bad. It's that TypeScript has a lot of pros and a few cons.
It's fair. It's a very balanced and neutral approach. I like that. Yeah, they think the same. How can smart people turn down the obvious superiority of culture?
Anders Hallsberg, the creator of C# and TypeScript and a couple other things that are important and big, has one of my favorite quotes is, show me a perfect programming language and I'll show you a language with no users. As we continuously develop programming languages, we learn what works and what doesn't work. So as soon as the language is perfect, it gets a user, we learn from it, oh, now we've realized something wrong. Yeah. Additionally, languages need to work in today's environments. You can't just make a language and expect everyone to use it. Like JavaScript is objectively not a great language to begin with, but we're stuck with it. So that's why we've been working on it instead of going to something like Clojure,
Nope. It reminds me, I'm trying to remember who said the quote about democracy not being the best, but the best that we found so far.
I think it was, democracy is the worst political system except for all the other ones.
Except for all the others.
Something like,
yeah. There we go. Much better when you say it correctly, as it turns out. But yep, and some agreements. More productive with TypeScript. Yeah. Ooh, I don't know what this question is asking, but maybe you do. Dependent types?
Yeah. So this is a very good question. It's a feature that we would love to see in TypeScript, but is very computationally complex and is likely not to be added to the language in the next few years. In order to actually explain it, we'll need to go over some more TypeScript fundamentals. So can I like put this like lower in the stack? Yeah.
We will come back to it. Feel very good question. It sounds like.
So. Very good question. This is someone who knows what to ask about. This is someone who's worked in TypeScript or at least read up on it before.
So, okay. What do we need to cover to understand Fuel's question?
Sure.
For the rest of us.
So like, what is TypeScript? And then types, or like the type system, type annotations, object types. This is roughly in order I can propose we start, and we might change this over time. Like we basically covered like what is TypeScript? Like it's a superset of JS. It is also the set of tools that take your .ts, tsx code and type check transpile, which is, by the way, a point of confusion in the community. The word TypeScript both refers to the language, this idea of syntax, and a bunch of the tools around it. And those tools include the type checker, which looks at your code and gives you the red squigglies. The transpiler, which takes TS to JS files. And then it's also the language server, which is the thing that runs in an editor like VS Code, or this little friend here, this playground, and hooks up the type checker to the red squigglies. Does that make sense and sound good so far?
It makes sense to me. Obviously, folks in the comments sound off if there's anything that is confusing or you have a further question on. This is your chance to pick the brain of a genuine TypeScript expert. So
it horrifies me to be described as such, but I, for my own sake, won't disagree with it.
There's nothing more intimidating than being called an expert, even if it's something that you know a lot about. So I feel you.
It's so weird. Like, who am I? Anyway,
but I think you did. System. You literally wrote a book on it, so I think we get. I think it's a title you've earned.
Thank you. I appreciate it. Let's talk about the type system, which is my favorite topic, as opposed to me, which is my least favorite. Let's say my name equals Kathryn. I spelled your name right?
Yeah.
Okay, good. I'm always paranoid, even though I'm literally looking at it in front of me. Okay, so my name, this variable is type string. If you hover over it with your mouse, this is TypeScript deducing ingeniously, very cleverly, that, okay, its value is string. So if I say, sorry, value is type string, so like my name is Josh, that's okay. Smiley face. But if I do something good, if I say like 9001, then we get a complaint. And in fact, I can show you that before we go into that complaint, we see that there is one, that there's a type error, but TypeScript is still able to turn this into JavaScript. Because although there's a type error, this is still valid JavaScript syntax. So there's a separate process of transpiling, turning your TS code into JS, and type checking. That sound good so far? Cool. And then if I click over this tab, we get type numbers not assignable to type string. Whenever you create something, say a variable in TypeScript land, TypeScript will take a look at it, understand what its type is, and then every other time you use that thing, let's say that variable, it'll make sure it's used properly for that type. For example, if it's a string, you can only ever assign it another string. You can't assign it some random other thing like number.
Right. So it works, it sounds to me kind of like a linter, but around rules that you've defined instead of like an agreed upon set of necessary like best practices or something. Because I know there is also a linter specifically for TypeScript, so I'm probably crossing some wires here.
You are, only because we as the community have decided arbitrarily what to call different things, but the thinking of this as a linter is a good way of thinking of it. This is like what I go over in open source, but like there are 3 common forms of static analysis in the wild. There's the formatters, such as Prettier. There's linters, such as ESLint, and then there's type checkers, such as TypeScript. I should put EG so people don't get mad at their favorite project.
The only linter available, yes.
But yeah, TypeScript, type checks, and lint complaints, both are things that I would describe as the red squigglies. Like if you're in a Word or Google Doc, then like the little like, oh, you spelled this wrong. That's a good way of thinking of it. Cool. So actually, could you highlight that comment from Boss Fighter?
Oh yeah, absolutely.
It's a great question.
Should you write one? This one? Or
yes.
Great.
Yes, thank you.
Absolutely.
This is a great thing to bring up, because in TypeScript you can add optionally type annotations. This is the first new syntax here. And notice that this type annotation is only in the TypeScript code. It's not kept when we transpile down to JavaScript. This is the superset. This is the stuff that TypeScript adds the language on top of JavaScript. Now, two reasons why I would say no, you would not generally want to write that. One is that, fun fact, in JavaScript, not TypeScript, JavaScript, there's a difference between lowercase string and capital string, because capital string, capital S string, is like new string, like doing this with, which is like this whole weird convoluted thing we don't want to get into. So this is the class-based string. We want the primitive string. So primitives like numbers, Boolean strings, lowercase. Secondly, this is an example of TypeScript causing you more pain for no gain. You're saying let my name string equals Kathryn. We know it's a string. Like that, there's no purpose to writing this type annotation. If we had like decided later on what it is, then we could have added a type annotation to tell TypeScript like later on this will be a string. But if it's inferable from the initial value, there's really no point to it.
So this comment here had it on the notes, it sounds like, that
Yes.
TypeScript can deduce the type from the value.
Yes. And that's, in my opinion, generally most of the time the right way to do things. Only sprinkle in these little type annotations when there's benefit to doing so, when you're telling TypeScript something it wouldn't already know. Most commonly when there's like a variable or something that doesn't have an initial or default value. If you leave it out, it's the any type, which for those who weren't here earlier is the I don't know what's happening, shut up, YOLO, don't yell at me. It can be anything. We don't like that because look, now my name is allowed to be a string or a number or who knows what.
So on that note, are your options only to define it as one type or any type, or can you say it could be a number or it could be a string?
I love this. Are you? This makes me so happy that you're asking this. So we've covered type annotations. Let's add union types in before. This is actually how I teach things in the book. Was this intentional that you're asking this great question in that order?
No, I'm glad to be helpful though. But I say again, as much as I would love to be like, this is an act that I'm putting on, and I actually am a TypeScript expert and I'm just giving you leading questions. I actually am a total TypeScript novice and can know just enough to get by, but without understanding a lot of the like underpinnings of why it works or why we do things that way. So all of my questions are genuine beginner questions.
Perfect. This is a great question to ask. Because you're totally right. And I think the reason why you're asking this is because you, Kathryn, are like a very experienced JavaScript person and you're thinking in terms of JavaScript. And in JavaScript land, very often something can be one thing or another, such as it could be a string or undefined, which is, of course, then if it's common in JavaScript, it must be modelable in TypeScript. And this is what's called a union type or an or. It's either a string or an undefined. So maybe name equals I, maybe name equals undefined. These are both okay. But if we do like maybe name equals true, that's still not allowed.
Right.
Or is Boolean not assignable to string. Yep, you are totally right. There is a way to do that. And this can get more complicated. You can do like string or number or undefined. Or like string array. This is the syntax for like an array of something.
Mm-hmm.
Or null, because in JavaScript we have two null values, which is silly. Now, I will also say that there is an even more granular option that you can go towards. These string or number types, these are primitives, but you can also do literals. You can say like let exit code and be like 0 or 1 or 2.
Okay.
You can do that. And these are literal, which is not the same as a primitive. A primitive is anything of that primitive value type, like string or number. But a literal is a literal example of that.
Specific. Yes.
Mm-hmm. Yes. And you can think of primitives as a union of every single possible literal of that type. Like string is actually blank string or A or B or C.
Right.
Infinitely. And I actually just realized this yesterday talking to someone. This is a good proof of there being multiple infinities in the TypeScript cinematic universe because there are infinite number of strings and infinite number of numbers. So like string or number is 2x infinity. Math is hard.
Yeah. Okay, I'm going to interrupt you because we've gotten a ton of really good questions, I think, in the chat. So I'm going to kind of work from the top down and we'll see, we'll cover as much of them as we can. So you have a complex type, is it better to add the type?
We haven't covered like complex object types yet, but spoiler, that is something if we have time we can. It depends on the situation. I'd say yes. If there is a complex object shape that you use multiple times, I would generally recommend defining an explicit type for it. That way you can give it a name, so that if you have like weird type errors, it uses the name and not some like convoluted explanation in line of the type. And it's just like easier to think of things like as a documentation point. If you have something being reused, it's nice to have a single place to point finger at and say, this is the term for that. This is how you should think of it.
I also like this one that was like, can you define a number type that doesn't include not a number, basically?
No.
So I like this, I think, is an interesting question. Also, just like, can I say everything but? So even if I'm willing to accept all numbers except 2, can I do that?
I'm going through the TypeScript issue tracker because I believe there is a negated type thing that they've like off and on looked into. Self-type checking. Oh boy. Here we go. So yeah, they've experimented with the concept of negated types. By the way, the TypeScript team collectively has an excellent sense of humor. Long have we spoken of in Hushdom. This is not in TypeScript. It's an yeah. How hard can it be?
That cracked me up. Sorry, go ahead.
Clearly, if you have a list of people like this person and all these people on there that have experimented with, it's yeah, no, there's no way to do it because it's very like intellectually complex. Like the concept of a negated type is really tricky. Also, specifically for a lot of the common use cases, you can't actually guarantee something's not there. Like you can in the type system say my number is never going to be not a number, and then introduce a bug that accidentally turns it into not a number. Like that's kind of common. So it's similar to how in TypeScript there's no way to annotate what type of error a function throws. It's not really something the type system can reasonably enforce.
Next question. I'm blazing through these because we got a ton and I want to cover as many as we can. If you mark a variable as optional, is that the same as saying like this or undefined?
So you can't use the question mark syntax in a variable, but let's talk about object types.
Sorry, I know we're like bouncing all over and you had such a like nice outline, but I just want to cover I want to answer as many questions as we can while we've got the time.
yeah, no, this flows well. So there are 2 ways to do object types. I'll show one of them. The 2 ways are roughly the same, but like interface, my status, whatever, or I don't know. I saw Dragon Ball Z at a sushi place last night on the wall projected. So fighter is like name, string, power level, number. So in this interface, I have said that anything that I want to call fighter must satisfy this structure. TypeScript is a structurally typed language. So let fighter equals object. And I have forgot to put name. So let's put like, I don't know, like Goku or whatever. And then, okay, we're good. Now I'm actually just going to comment out all these error things because I don't want it yelling at me. But when we put question mark, we're saying that this property does not have to exist. If it does exist, it has to be a number. But it doesn't have to exist. This is not the same thing as saying that power level can be number or undefined. When you say that something is optional, you're saying it doesn't need to exist. If you say that something is whatever or undefined, you're saying it must exist even if its value is undefined. There's a slight difference there. So here, if I leave out power level, it still tells me it's missing, even though I could explicitly say it's undefined.
That was cool. That was sense. A very good question. I would not have thought about that. And that was a really interesting distinction. So good call.
Cool.
Okay. I think I've got through all of them. So back on track.
Awesome. So let's talk about structural typing a little bit. So I declared this interface here, interface fighter, and I declared a variable let fighter : fighter. And let's say I want to like announce fighter, which takes in a fighter. And fun fact, you can put type annotations on parameters. So I'll say like my fighter is a fighter. Target name, fighter dot power level or flat. I don't know. This is saying that in my function, when I call announce fighter, I have to pass in something that satisfies the fighter interface. So anything that matches this structure. I'm going to go with the optional, so it's easier for us. However, TypeScript is a little different from a lot of other type languages in that you don't have to explicitly say that something is a particular interface. It's totally fine to just pass a value that coincidentally happens to match the type described. Notice here that I never said that this fighter variable is a fighter. And if I hover over it, instead of saying let fighter : fighter, it's let fighter this object type that has a name string. But because it structurally just so coincidentally happens to match with the interface, TypeScript allows it.
Okay.
Kind of cool, right?
It is. I'm like trying to think of where. So if you were to add even one other value that didn't align, then right, it would not allow it.
It would allow it.
It would.
Because this object just so happens to satisfy the structure of interface fighter. Which is, actually, this might be a reason why you would want to explicitly say that something is a fighter, because then it would let you know, hey, you added this ASDF property, which is wrong. But you don't have to. For example, if you have like interface fighter, and then you also have like interface with name, which is just like name string, and then const announce with name equals name with name log, whatever, and then you said announce with name fighter, this would be okay too. So this value just happens to satisfy all sorts of interfaces.
A couple more questions that came up because I'm trying to keep an eye on the chat for you. So, does a trailing comma on the last value pair need to be there?
No, it does not.
Cool.
TypeScript, much like JavaScript, does not enforce trailing commas when they're not needed, but Josh, like to do it.
I think it's a good habit because that is an error that I make all the time where all of a sudden something's not working and it's because I forgot that there needed to be a comma there. So full support. What happens if you put any instead of fighter type?
So yeah, this is a case where let's say that your fighter type doesn't have 2 properties. It's like 15 and it's super complex. Yeah, it's totally fine. If you need to put an any, nothing would yell at you. It's just nothing would stop you from doing fighter dot whoopsies.
Right.
So, yeah.
I mean, an any just says it'll accept literally anything, right? Like kind of like deleting or turning off a rule in a linter, right? It's just not going to check for that at all anymore.
Yeah, exactly. Which is, if
you use any, it turns into JavaScript.
Yeah, really. Writing JavaScript is like writing TypeScript with any's all over the place. Like that's rough. Like TypeScript is still, fun fact, TypeScript is what powers a lot of the JavaScript tooling in editors like VS Code. So it quite literally is like writing TypeScript with a bunch of any's.
I did not know that. That's cool.
Yeah. TypeScript actually supports type checking JavaScript files. For example, there was a big hullabaloo on TechTwitter recently because a major open source project, Svelte, announced that they were, quote, dropping TypeScript, which is an inaccurate quote. I think the quote wasn't from them. It was like a couple of articles that got written separately. What they were actually doing is they were just dropping TypeScript syntax and instead using .js files with JS doc comments, like param, fighter, and then like doing it as in JavaScript. The advantage of that is that you can then directly run your .js files, your source code. You don't need to transpile. The disadvantage is that the syntax is an objectively, I think, worse way of describing types. It's more convoluted and it lacks a few features.
Cool. Okay, I'm done distracting you with questions.
Oh, sure. This is most of what we would want to cover for TypeScript. There are like a couple more things. Let's talk about.
We have a request in the comments for classes.
Oh boy. Let's not talk about that. So Most of the information around classes is just how to do them in JavaScript. So if you know JavaScript classes, you know them in TypeScript. We can cover them briefly. So like, I always put this as optional because a lot of code bases, including most of the ones that I work on, very sparingly use classes. But you can define a class like, I don't know, class box that has a value string or whatever. This dot value equals value. So yeah, you can add type annotations to the constructor parameters, just like any other function. And you can add type annotations to the properties of the class. And depending on how your JavaScript syntax is transpiled, this is like the traditional way of transpiling syntax. The built-in TypeScript transpiler, which you don't have to use, also supports, where is it? There's like a way to transpile class use define. There we go. So like technically the way JavaScript works is if you declare something like this, use object.define property inside. This is a JavaScript thing, not a TypeScript thing. It's a whole discussion. So TypeScript can consider your code as doing that. But again, this is like mostly TypeScript stuff. This is mostly JavaScript stuff. Most of the TypeScript additions are just the fact that you can type check and add type annotations.
Gotcha.
Make sense?
Yeah.
Cool. Let's talk about narrowing though, because narrowing, I think that's much more cool. So let's say you have a let or const name maybe equals math.random greater than 0.5, which is either, I don't know, Anders or undefined. Now, fun fact, if you hover over this variable, it won't say string or undefined, it'll say Anders or undefined because it's const. TypeScript knows you're never going to reassign it to a different string. So it's not the primitive string, it's the literal Anders. Nifty, right? Yeah. And if I do this, const.log name maybe dot to uppercase, this is going to yell at me because what if it's undefined? If I were to run this code, which fun fact the playground can do, half the time it'll give you a little error. It's not good. So if you were writing this in JavaScript code, you might do something like that operator. Or just to be more explicit, you might do like if name maybe.
If it's
yeah. Let's put that there. But wait a second. TypeScript is being smart. Notice the lack of error here. TypeScript has narrowed the type, where it knows that the only way for the body of this if statement, the block here, to be executed is if name maybe is defined, if it's a truthy value. So in here, name maybe is just Anders. It's not string.
Ah. That is very cool.
Right? Most programming languages don't have this feature. And there's like a nice little feature in the playground where you can, little 2/ comments they're called. You can just ask, hey, can you just print out the type of something? And if I were just to make this a little more clear, if I just switch it to a let, it's still string or undefined. If name maybe, now it's string.
Interesting. I'm trying to think. I feel like 99% of the time, I feel like that would be immensely helpful. And I feel like I would find the 1% of the time when I had accidentally narrowed something unintentionally. Does that happen? Or is not really enough to worry about?
Not enough to worry about. TypeScript's pretty gentle and tries not to get in your way. I will say, though, that scoping is tricky. Like function populate name maybe. So like, let's say we have this thing. What's a name? Give me a name.
Megan. It's my sister's name. There you
go. What's her name, Megan? Today I learned. Cool. I have a friend named Megan who just got engaged. Congrats again, Megan. This is actually dependent typing, by the way. What we're getting to this. So TypeScript doesn't know that if you call populate name maybe it's now defined, even though we know this code will never throw an error.
Right.
Why is it? Okay, must have been a script. Yeah, it'll never throw an error. TypeScript's type checker type system is not fancy schmancy smart enough to know that this name maybe variable's type is also dependent on calling this populate name maybe function. This seems like a very simple case, like, oh yeah, just let it know that if this function is called, maybe. But then like it gets really complex. You have functions calling each other and complex logic and like set timeout and stuff like that. So TypeScript does not have dependent types, but there are kind of cool research projects to try to make a version or an equivalent to TypeScript that do have dependent types. None of them have hit the point where you could use them in like a real company though.
That's pretty cool. So we made it all the way back to your original question. Cool.
Very exciting. There's one last thing that I want to show that combines type narrowing, literals, and unions in a lovely named features called discriminated unions. But I want to pause and give you the opportunity to throw other questions at me in the meantime.
Ooh, I think I've been pretty good about just shamelessly interrupting you to ask my questions. But
Perfect.
Chat, as always, your chance to sound off. I think we'll probably be on for another 15 or 20 minutes, I'm guessing, just kind of based on the pace we've been working through. So if you got questions either related to what we're doing or just general TypeScript questions, or maybe just want to ask Josh something non-TypeScript related, I won't stop you. I'll stop you if it's weird.
Yeah, please stop them if it's weird. But
I'll stop you if it's weird.
Awesome. Well, not to try to risk it getting weird, but let's talk about discrimination. Sorry, discriminated type unions. That was a legitimate mistake, not me trying to be funny. Discriminated type unions. So it comes from the same root concept as the concept of discrimination, as in you're separating things out. And truly, I wish we would find a less risky term. But let's say that you have a value that's, now I've made it weird. Sorry, not intentional. But let's say we have a value that results equals, again, like a 50-50 chance of success, true, value, yay, or success, false, error, new error.
The literal coin flip, right?
Exactly.
Yeah.
Value, let's call it heads, error, new error, tails. Even though I personally don't use errors as like a form of control flow, blah, 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 blah. Anyway, the TypeScript type system ideally would be smart enough so that it knows result.value doesn't necessarily exist. But the default type for a result is actually kind of like weird. There we go. Where we know success is a Boolean because it's true or false, and we know value is a string and error might exist if it's undefined, or it's error with a particular. This is weird. So I'm gonna start using a feature called type aliases, where when I say type success result, what I actually mean is success, true, value, string. And when I say error results equals success, false, error, error. And then type result equals union of it's either a success or an error.
Okay.
Cool. So now we know that the result is, well, it definitely has a success that's allowed. Result.success is okay. And that's a Boolean. But that's all we know that it has. In fact, actually, just so I'm not confusing syntaxes, we can just represent this with interfaces. It's singular, because I don't like introducing new syntax stuff late in the game. So let's just call these with interfaces. Okay. My verbal gaffe earlier threw me off my game. So we can say result is an error result or a success result, or we could call it a type alias. Either way. But TypeScript is smart enough to say that we know result doesn't necessarily have a value because value doesn't exist on the error. So we haven't ensured, similar to before with the if name maybe, we haven't ensured that result.value exists. But what we can do is if result. I'm testing loads of typing. There are puns to be made. If result.success is true, then we know that result.value is true. Oh, pardon me, exists. Because if result.success, then the result is the success result.
Nice.
Does that make sense?
Yes. I do want to go back and ask a question about something you said, and it was actually super offhand when you were defining the new error there. You were like, but I don't actually like to do this. Why? You were
Oh,
talking
why I
about
don't like using
using
errors is
errors to, yeah, go on. What were you saying?
this is like totally separate from like JavaScript, TypeScript, whatever. But just in general programming, I don't like using throw new error or throw whatever as
Okay.
as a control flow thing because it's very difficult to do at scale. If you have all sorts of functions all over the place that might throw an error, it's very difficult to keep track of who's going to throw what. So I'd rather have explicit return types, such as with a result like union like this.
Gotcha. That makes sense. I wasn't sure if there was like a TypeScript thing, like, oh yeah, you want to be sure not to do this because it will have some compounding effect that you're unaware of. That makes sense generally.
Cool.
The question: can we define two functions with the same name but different input parameters?
You're asking about like function overloading the way that like Java or C# allows it. You can only define a function once. Pardon me. There's because it all compiles down to JavaScript. If you define a function, let's say populate name maybe, you can't then later on say like function populate name maybe with value string and then like do another definition there. There is a TypeScript feature that I do cover in my book and very rarely recommend to use called function overloading, where you can define where is it? There we go. You can define multiple signatures for a function. It's an overload, so that when people call it, they can choose which one to call. So the first two are the overload signatures, and then the last one is the actual implementation, like the internal one. I don't generally recommend getting too deep into this too early, and I kind of regret putting it in my book because it's very rarely relevant or used, and I find it to be kind of confusing. But it's for cases where you have like APIs that like have a different name for like is string or something, or like you can only provide a value for a number. Like if there's a case where like you only want to be able to provide that second parameter if the first one is a number, like weird complexities like that.
It is. I'm like chewing on that. Like, how would that even compile down into JavaScript?
These are a type definition, so they're completely erased.
Got it.
And this is just the JavaScript.
Okay, cool.
Cool. But yeah, this is not a common thing. It's mostly for like weird and wacky APIs, which in general we try to avoid in programming. Cool. But if you don't mind, I do want to point out how cool this stuff is. So this is a discriminated. Yes. It's called a discriminated union because there's a discriminant property, the success one, and a type system such as TypeScript that is able to understand these things can narrow the type of something based on that discriminant. If result.success is true, then result is a success result. Otherwise, result is an error result. And this is like a more advanced form of type narrowing, where instead of directly checking something's type or whether it's truthy, we're checking a property, a discriminant property on the type. And I think this is really cool. This is like how I normally end my explanation introductions, because this is showing off that like there's some surprisingly nuanced stuff you can infer in the type system. But I'll also say that it's totally okay if anyone here watching is like completely lost. Like this does not come up very often.
So, I try to think about where do you want to start? Like, man, I do want to go back and change some of my stuff now because I am sold.
Yeah.
So success on that front, in that like, I see why people are excited about it now.
Yeah, I'm glad. But I'm curious, what about all this stuff we've gone over has been particularly convincing or not convincing for you?
I think the moment where I was kind of sold was the inference, when it was like, oh, like TypeScript can infer the value, right? Or the type from the value. And I was like, oh, it's really smart. And it made me feel like it wouldn't be, in my mind, I was imagining like, I'm going to have to define a lot of stuff manually, and then they'll want to change something and have to go back and change it in 5 different places. And that sounded frustrating. Yes. And I think I was I think I was a little bit stuck on like earlier when I compared it to like prop types, and I was like, ugh, like I understand why we do that, and it's important, and also it's kind of a pain in the ass sometimes. And I was just having this vision of like, oh my god, every single variable in like the whole application, I have to spell out in the specific way, and then when something changes, I have to go back and change that whole structure. And it sounds like that would not be the case as often as I was imagining that it would be the case.
I think so.
Because it's smarter than I thought it would be in terms of what it's able to do. So when you're talking about like the narrowing and the like type inference, that made me feel like it was less that I would have to be spelling out every single direction, which sounded tedious and unenjoyable at the time. So.
Yeah. Especially in React code bases, what I found, what happens most of the time is people end up just defining props, like interfaces or object types for their props, for the components, and function parameter types. And that's about it. I'll also note that a lot of people just end up writing less code when they switch to TypeScript because they were already documenting the types of things in JS doc comments, and now you don't have to use that slightly more verbose syntax anymore. So amusingly, TypeScript ends up being less code for them.
That does make sense. That's interesting that you said like in React it's used this way. Do you feel like the way that people use this tool differs pretty significantly, like framework to framework, or?
Somewhat. I think.
I just thought that was an interesting way that you phrased that. So if I read into it too much, you can tell me like, no, like chill.
No, not at all. I'm just going to reply in the chat with someone asking me about my book. That is TypeScript or learningtypescript.com. Thanks for asking. The general philosophy of component-based frameworks like React and Preact and Solid and all of them, and Angular, works really well with type systems because you have really clear delineations of input and output. This component takes in whatever the props are. Similar to how there's comment about this now, like APIs that have predefined contracts, like in GraphQL, TRPC, and so on. So any system that is well delineated that way, you end up writing types very often just or mostly for your boundaries, like say component props. Similar to how you would just end up like having function parameters being documented. And I think that a lot of the success of TypeScript has come from it existing mostly as a form of documentation, dev tooling, bug catching for JavaScript, not like new runtime features, because people naturally gravitate towards stuff like GraphQL, TRPC, React components, and so on that are relatively easy to model because they're relatively easier to think about mentally.
That makes sense. Okay.
Cool.
All right. Well, I think that sounds like we're at a pretty good wrap point. I'll throw out one last call for any questions you wanted to slip in. And in the meantime, for folks that missed your introduction, obviously we've hyped your book up a little bit, which rightfully so. Where can people find you online if they want to hear or see more of you?
I would love that. And y'all definitely let me know if you have any questions or things to talk about with TypeScript or open source or anything. I'm Joshua K. Goldberg. Joshua K. Goldberg. I would say I'd type it in the chat, but I've already been in the chat. Y'all can find me there. On Twitter, Fastodon, Blue Sky, GitHub.com, Twitch, and YouTube. So I'm this everywhere. Fun fact, I don't go by Joshua, I go by Josh. But yep, that's why. And then also I'm a full-time open source maintainer to redo the intro. So I don't work for any particular company. I'm independent. I work on stuff in the TypeScript ecosystem, most notably TypeScript ESLint, which is the tooling that lets you run things like ESLint and prettier on TypeScript code. So if y'all have any questions about that, hit me up. I'm actively working on it and very excited about the things we're working on.
Awesome. Well, thank you so much again for coming on. This was truly, really fantastic. Chat also seems appreciative. We were super glad to have you on. And yeah, this demystified a lot for me. So much appreciated, if only personally, that I got a little over an hour of TypeScript tutoring.
My pleasure. Your bill's in the mail. No, this was fun, and I really enjoyed it. And yeah, I like spreading TypeScript knowledge. I think it's a really useful, cool tool. I think we should understand the pros and cons. There are a few cons and a lot of pros. So good stuff.
Yeah.
Happy to be here.
All right. Well, thank you, chat, for tuning in. We will see you all later. Have a good one.